Hey guys, dynamic milling is all the rage right now. You take a solid carbide end mill, execute a heavy depth of cut using your flutes, and a light radial width of cut with lots of very fast moves to remove your material. It is relatively fast, it's fairly easy to program, but it involves a pretty expensive tooling choice in a solid carbide end mill, and it's very limited in terms of how deep this application can be utilized. I'm here today to show you an approach that's actually more effective, more cost effective, and much less limiting in terms of the total depth of the part that can be machined. It's called HighFeed constant profile ramping. We're going to use both a HighFeed end mill and a HighFeed shell mill to demonstrate this approach. And in this video, I'm going to show you how to program it, and I'll show you comparisons between the solid carbide end mill, a HighFeed end mill, and a HighFeed shell mill, and we'll see just how they match up. Alright, so here's our block of material. This is about a 6-inch wide by 8-inch long piece of 4140, and you can see within that block I've created 2 rectangular openings for us to machine. We'll start with a dynamic milling routine, and I'll select the lower rectangle as my region to work. And the tool we'll use is a 1/2-inch diameter solid carbide end mill. We'll run that tool at a surface footage of 800, which for 4140 pre-hard is pretty fast, but because we're using dynamic milling techniques, the radial engagement will be light, which reduces the heat we're creating, which allows us to run that tool faster. As far as a feed per tooth, recommended for a 1/2-inch solid carbide end mill is generally 1 thou to 1 thou, but because of radial chip thinning due to the dynamic milling approach, we can actually feed this tool at 4 thousandths feed per tooth, which puts us at 98 inches a minute. Let's just round that off to an even 100. We'll let the plunge rate be 50 for our helix. And if we move on to the cut parameters, the recommended step over for dynamic milling for this tool will be 10%, which will be 50 thousandths width of cut. We do not need to leave any stock. This is purely a roughing demonstration. And the entry motion will be a helix. We'll let it helix with a 1/4 inch radius, or half the tool. We don't need to start at 1/8 of an inch over the part. We'll start at 50 thousandths. And this solid carbide end mill can actually ramp very aggressively at 5 degrees for the entry. And then our linking parameters will set a safe clearance plane of 1 inch above the part. Our feed plane will be 50 thousandths above the part to start our helix. And we'll take the pocket depth to 1 inch for the purposes of this demonstration. And we'll give the computer a moment to calculate the tool path. There we go. So now let's open up a verify window and take a look at what our tool path looks like. We'll slow down just a hair here so we can see. So we're helix down to the 1 inch depth, and now the dynamic tool path is creating an ever increasingly large circle to open up to the width of the pocket. Speed up just a little more. And once it reaches the width of the pocket, it works its way into the corners, and then we'll just execute an ellipse towards the opposite end of the slot. This won't take long. And when we reach the end of the slot, we see that we have a total time of 6 minutes and 3 seconds. So that's the cycle time to create this pocket that is roughly 5.5 inches long by about 3.5 inches wide by 1 inch deep. Using the dynamic milling approach is just over 6 minutes. Okay, so now let's take a look at roughing out the same size pocket using the HighFeed constant ramp profiling technique. So now instead of going to dynamic, we'll just pick the first option on Mastercam, which is contour. Again, I need to pick my profile, so we'll pick the upper profile. And this time, we'll use the easier one of the two tools I intend to demonstrate. We'll use a 2-inch diameter HighFeed shell mill. This is set up with a 600 surface feet speed and a feed per tooth of 44, which is 250 inches a minute for this tool. Our cut parameters, this is the key point. You go to your contour type, and instead of a two-dimensional contour, we actually want to execute a ramp. And then you have the option on ramping of either cutting at an angle or cutting at a specified depth. For HighFeed, we want to maintain a consistent depth of cut. So for this tool, I'm going to program 40 thousandths depth of cut per pass, which means every time the tool travels around the periphery of the pocket, the Z level will have gone down by 40 thousandths constantly. So we've got what we need there. There's no stock left. Let's go to a lead in and lead out, which we actually don't need, because with constant profile ramping, you begin your ramp entry right on the profile of the contour, and there's no lead in or lead out necessary. So it's a time saver in that regard. Go to the linking parameters. We will program again with a 1-inch clearance. Let's set a feed plane of 50 thousandths, and again, we'll travel 1 inch deep for the pocket. And we've got what we need, and the tool path generation is very quick. So let's take a look at that path. Here's our block. Bring that a little bit closer and slow this down because it won't take long. And here we go, 2-inch shell mill. And you can see as it traverses the pocket profile, it's just working its way downward in Z. There are no entry and exit moves. There are no separate plunge moves down to a particular depth of cut like waterline roughing. This is strictly a constant ramp all the way to the bottom of the pocket. And when we reach the bottom, we have a total cycle time of 1 minute and 5 seconds. Compare that against the 1/2-inch diameter solid carbide end mill using the dynamic milling approach, which took just over 6 minutes. And you see that this is a huge time saver using the 2-inch diameter HighFeed shell mill. Now let's take a look at this same pocket, and instead of using a shell mill, let's drop down to a typical HighFeed end mill and see how that compares. All right, so finally we'll rough out the same exact pocket, but this time instead of using a 2-inch shell mill, we'll drop down to a 1-inch end mill and show a little bit different approach for roughing a pocket of this size, because we know this pocket is about 3.5 inches wide. So a 1-inch end mill isn't going to be able to clear all of the material from that pocket with one pass. So what I've done is taken the finished profile of that pocket, and I've actually offset it inwards by 3/4 of an inch. So now I actually have a smaller inside pocket and then the final outside pocket to use for my constant ramp profile technique. So again, I'm going to go to contouring, and this time what I'm going to do is select 2 profiles in the order that I want them roughed, and we'll call that good. And my tool this go around is going to be a 1-inch end mill. HighFeed, 240 inches a minute is 30 thousandths feet per tooth at 700 surface feet. These parameters, by the way, for the HighFeed are very run-of-the-mill conservative parameters. You could expect, even in 4140 pre-hard, running at these numbers, you could expect upwards of 2 hours worth of tool life per corner. And remember, this is an indexable tool, so you're going to get multiple edges of use out of each insert. Makes this a very, very economical option, even setting aside the cycle time savings. So our cut parameters here, again, I'm going to go to a ramp. My depth for this smaller tool, let's be conservative. Let's say 25 thousandths depth per pass. My lead in and lead out, again, is unnecessary. And my linking parameters, we'll again use 1 inch as a safe zone. We'll feed at 50 thousandths above the part, and we'll take the pocket to a depth of 1 inch. And we're good to go. Again, that quickly, we've got our tool path. So again, let's take a look on the verify screen and find out what the cycle time is for this tool. Bring just a hair closer. All right, so our 1-inch end mill will first rough out the inside pocket. And when it has that completed, it will move to the outside. You can see we just had enough there to clear out the material. I probably could have even offset a little bit more, but for the sake of the demonstration, it works. And once we reach the bottom, we have a cycle time of 3 minutes and 31 seconds. So even taking 2 passes with the HighFeed end mill, we are almost half the time of the solid carbide end mill using the dynamic milling approach.
So there you have it. HighFeed profile ramping is actually more effective than dynamic milling with a round tool in many cases. Keep in mind too that we're executing this approach with a much more cost-effective indexable milling tool that can be used multiple times. Additionally, the length of an indexable tool is your only limiting factor for the total depth of your pocket or your part profile that you're machining with this approach. With a round tool, your depth is limited by the flute length on your cutter. If you need help with this application, contact your DAPRA application specialist today and we'll be happy to help.